Okay, we'll take a look at this next section. As we start to look at radian measures and the unit circle. So we'll look at finding points on a unit circle determined by different real numbers, converting between radians and degree measure, finding coterminal, complementary, and supplementary angles within radians, find the length of an arc of a circle, and find the measure of a central angle of a circle. So let's take a look at this first slide here as we define the unit circle. So remember a circle equation, we talk about the standard form. All right, I'm going to put up here, right here at the top, just a little review back to our conics and circles. Standard form equation of a circle is what? X minus h squared plus y minus k squared equal to r squared. All right, so we look at a circle, we have the sum of two squared terms, the x and y term, and within that we see that the coefficients of both can be reduced to 1, and if we can create the squares with x and y, we can see what we call the x and y coordinates of the center point. That's these values of h and k. So we know that the center of this circle would be at the ordered pair h, k. And we know the squared term, the constant term on the right side of the equation, right, allows us to find our radius. So we can take the square root of r squared, and radius our distance from the center at any point in the circle. So when we look at a unit circle is a circle centered at the origin with a radius of 1 unit. So again, if you think about the standard form equation, that's x minus h, the x coordinate of the center, which is at the origin, 0, plus y minus k, y minus 0 squared, equal r squared. So simplified down, we get x squared with y squared equal 1. So that's our unit circle standard form equation. And so if we were to graph or look at this circle, right, we would plot that in here. So down here at the bottom, let's go ahead and look at a picture here of our unit circle. All right, we know again we're centered here at the origin, 0, 0. And we know the distance to the center at any point on the circle is 1 unit. So we could even plot these intercept points, right, looking at the unit circle. So again, there's our horizontal and vertical distance. But again, any point on the circle, right, if we were to look at the distance to that point, that's r, right? There's our radius. So again, we've got our radius, 1 unit, and we're centered here at the origin, center point. With that said, if we talk about the distance that we travel around a circle, all right, if we were to go on a circle, remember our distance around a circle, that's circumference. I'll write that up here. Circumference allows you to find the distance traveled around a circle, right? That's circumference C equal to pi times diameter, right? Right, which is equal to 2 times pi times radius, because we know diameter is twice radius. So again, we can look at it as 2 pi r. So in a unit circle, we got 2 times pi times 1, which is 2 pi. So yeah, the distance traveled around a circle, if we can travel here together counterclockwise, all right, we're going all the way around full circle, 360 degrees. Right, we traveled a distance of 2 pi radians. So again, we're finding our different radian measures with respect to the circle. So again, that's our circumference, right, as we look at that. Now within each quadrant, so remember, we travel around the circle, right, 2 pi radians. What do we do if we travel around the circle, right, halfway? Right, what's halfway? What's half of 360? So we're looking at that. That would be what? Pi radians, right? Halfway, half of 2 pi. All right, each quadrant represents 90 degrees. Now in radians, so if you think about this point right here, we would travel here in 90 degrees. Well, 90 degrees, of course, 2 pi radians, which is 360 degrees. We know that's 1/4, right, of 360. That's 1/4 of the way around. And 1/4 of 2 pi, right, is pi over 2. So again, 1/4 of 2 pi. Again, as you reduce that, I'm going to show a work up here at the top. That's equal to pi over 2. So you have pi over 2 radians, same thing as 90 degrees. Just like pi, we know is same thing as 180 degrees. That's 1/2 of 2 pi. We know 3/4 the way around. 3/4 of 2 pi is 3 pi over 2. Or 3/4 of 360 is 270 degrees. All right, which puts you down here. The order pair is 0, -1. And again, these are counterclockwise measures, right, as you see here in this unit circle. And of course, we could go clockwise with our rotation. We could take the same circle, right? We could travel clockwise, which would be what? Negative pi over 2, right? We could be near here negative pi. Here would be negative 3 pi over 2. Here's negative 2 pi as we travel all the way around clockwise. So again, you see your different measures. So the different special measurements, the intercepts, things we want to know quickly as we're looking at it. And that's what I've done here as we go to our next slide. So let's move on to our next slide here in the notes. All right, as you see here, again, looking at the different measures. If you think about the full revolution, 2 pi radians. Now pi, remember what we think about in pi, math, pi is approximately what? 3.14. So irrational number, that's 3.14. Again, pi is a ratio of what? Circumference to diameter. And as you look at this drawing here, again, that's 6.28 radians, right? Full circle. Pi radians, 3.14. So you just see in the relationship with the pi. And again, here your different intercepts. Every quadrant, right, 1/4 way around. You can see pi over 2, 1.57 radians, 3.14 divided by 2. You can see 3 pi over 2 radians, right, the 270 degree mark. And 3 pi over 2, 3 times 3.14 over 2 is approximately 4.71 in terms of radians. So you see it there as decimals, but we like the exact. We like to leave it in terms of pi. Sometimes they'll ask you to do some rounding and give an approximation. As we look at our special acute angles we talked about at the beginning of this chapter, right? We talked about our 30, 45, and 60 degree angles. Well, let's introduce those here in our unit circle. All right, we know that pi over 4, right, which is 1/8 the way around, right? It's right here in the middle of quad 1. 1/8 of 2 pi is pi over 4. You think about your 6 degree mark, right? 1/6 the way around is pi over 3 radians. So again, that's 6 degrees. So these are, again, our radian measures. Also, we can put them in degrees. 1/8 of 360 is 45. 1/6 of 360 is 60 degrees. So again, we can put those in degree measure. We could also look at pi over 6. We think about pi over 6. What would pi over 6 be in terms of degrees? We know that's 30, but that's what? 1/12 the way around, right? 1/12 of 360, right? Gives us 30 degrees. So again, you can look at your different measures there, radians, degrees. And let's take an example. Now that we've gone over our radian measures, we understand the relationship between radians and degrees. Radian measure our distance traveled around that circle. And the unit circle, right, its arc length is equal to the radian measure because the radius is 1 unit. We'll define radian earlier or later on in this section. Radian measure is the distance of arc length to radius. So on the unit circle, its radian measure is equal to the arc length. On the unit circle, mark the point determined by each of the following real numbers. So let's take a look at example A here. So let's draw in our unit circle. Do a quick picture. If you want, we'll put it here on the XY axis. Alright, so again, our unit circle. Alright, on a quick sketch, we're centered here at the origin. 0, 0. Radius is 1 unit. We'll plot some points. Plot the intercepts. 1, 0. 0, 1. Negative 1, 0. 0, negative 1. And we look at radian and degree measures. Or 0 radians, pi over 2 radians, pi radians, 3 pi over 2, and all the way around 2 pi, right? Radians. And again, the circumference, the unit circle, which is 2 pi, full circle, 306 degrees, traveled around. Again, if you want to look at them in degrees, we can put that in red, right? 90, 180, right? 270, and 360. And if you want, we could even label in the special angles. Pi over 6, 1/12 of 360, which again in degrees is 30 degrees. 1/12 of 360 is 30. All right, 1/8 of 360, 1/8 the way around is pi over 4 radians. All right, and 1/8 of 360 is 45 degrees. And of course we have, all right, 1/6 of 360, which is 60 degrees. So we're going to put pi over 3, right? 1/6 of 2 pi, that's pi over 3. And again, putting that here in degrees, 60. So I'd like to label those. We should be familiar with those. And we can do that within each quadrant. Look at our 30, 45, 60 marks. And that's what we're trying to do now. So if you look at example A, so in A, so where's 9 pi over 4 radians? Well, 9 pi over 4, let's think about 9 pi over 4. All right, so example A, I've got 9 pi over 4. Well, when I see pi over 4, I know that's a 45 degree measure. So that means I'm going to be at a middle mark of one of these 4 quadrants. Now, we might not be sure just right now looking at 9 pi over 4, but we've got a multiple pi over 4. So we're looking at a 45 degree measure. Now, let's go ahead and rewrite that to help us. Let's use some reference angles. Let's think about 9 pi over 4. Let's rewrite it as 8 pi over 4 plus pi over 4. And why do I like that? Because 8 pi over 4 is the same thing as 2 pi. So now I know exactly where to go. So if I look at 2 pi, right here is 2 pi. If I add, now remember I go counterclockwise. All right, if I subtract, I go clockwise. So here's a plus pi over 4. So as I add, again, here's 2 pi plus pi over 4. Right here is 9 pi over 4. It's coterminal, right, with pi over 4. So I can see my measure now. So here it is, my location, right here on the unit circle. So it's the middle mark. It's coterminal. So again, I'll write that note. Say coterminal angle. Say coterminal with pi over 4. All right, let's go to example B. All right, let's look at B together. And I like B. Now let's do it in a different color. Now in B, I've got negative 7 pi over 6. Well, I want to rewrite that. Let's look at one of our multiples of pi for a reference. So this time, let's say we look at negative 6 pi over 6. All right, well, negative 6 pi over 6 minus pi over 6. Well, that I like because I know exactly where negative 6 pi over 6 is. That's negative pi, right? So we've got a multiple of pi. So we got to go to negative pi and then subtract pi over 6. So let's go ahead and do that together. So negative pi, all right, we go clockwise halfway around. Right here is negative pi. And then minus pi over 6, that's minus what? 30 degrees. That's right here, our 30-degree mark in this quadrant. So if I subtract pi over 6, we'll be right here at this point. So locating negative 7 pi over 6, it's a quad 2 angle. So you see again, there in example B, right? There's our measure. So I'm going to draw a picture over there to that. But there it is, a quad 2. Third-degree mark. Right, so you can do that with any of them. So you think about these different measures, these multiples of pi, allow you to easily move and find their locations. And we can do as many as we wanted, right? We get as big as we want. But if I look at, for example, we've done a pi over 4 and a pi over 6 measurement. All right, how about a multiple? Let's add to that. All right, say we want to look at one more example. Let's make example C. All right, say I asked you to find negative 13 pi over 3. All right, and that's a multiple pi over 3. Where is that located on the unit circle? Well, I could break that down. That's negative 12 pi over 3. Right? We know where negative 12 pi over 3 is. That's negative 4 pi minus pi over 3. So again, that's negative 4 pi minus pi over 3. Where's negative 4 pi? Well, negative 4 pi, right, that'd be 2 complete revolutions around a unit circle. And if you want, let's draw that one in here. Let's go down here to see. Let's do a new unit circle. That one's getting crowded. So I'm going to draw it in here again. Draw a new picture. All right, let's put in our unit circle. All right, centered at the origin, 0, 0. All right, plot in our points, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. 0 radians, pi over 2 radians, pi, 3 pi over 2, right, and 2 pi. Looking at it there in radian measures. With that said, again, we could go clockwise also, right, with doing negatives. But let's take a look at negative 4 pi. So down here, as we look at negative 4 pi, right, we will go travel around 2 full circles, 2 complete revolutions. Right over here, here's negative 4 pi. So negative 4 pi, of course, coterminal with 2 pi. Any even multiple of pi, we're sitting on the point 1, 0. Any odd multiple of pi, we're sitting on the ordered pair negative 1, 0. So I'll give you a quick reference point. And again, minus pi over 3. Well, minus pi over 3, right? We're right here at our 6-degree mark. We got to subtract. We got to go clockwise 6 degrees. So right here is our point. So now I've located exactly. Now I know exactly where I'm located. Let's go ahead and draw that in here. Here's negative 13 pi over 3. Sitting here in quadrant 4. Negative 13 pi over 3. So marking that ordered pair. So the 6-degree mark, right, in quad 4. So there's examples to see. So you can do that with any of them. So use pi, 2 pi, right? Use those as reference. Remember, odd multiples of pi, you're sitting on the point negative 1, 0, and the even multiple pi at 1, 0. So you can use that to help you locate, because you want to know where your special measures are. Your pi over 3, your pi over 4, pi over 6. Of course, pi over 2. We're looking at those 90-degree, 270 marks. We're looking at our multiples of pi over 2. So we'll know your intercepts, of course, where they're located. All right, let's move on. Let's start to look at conversions between degrees, radians, degrees. And to do that, all we got to remember is that 306 degrees, of course, is the same thing as 2 pi radians. Yeah, complete circle, right? Circumference is 2 pi or 360. We think about our unit circle. So with that said, if we want to look at the conversion factor, so if I wanted to say, what's 1 degree, right, in terms of radians? Well, we would divide out on both sides, right? So I go right here beside it. If I had 306 degrees, I know is equal to 2 pi. Well, all we got to do is divide out 360 on both sides, right, to get our conversion factor from degrees to radians. So that implies 1 degree, and we can reduce together. Let's go ahead and reduce that. 2 divides into 1 time, 2 divides into 360, 180. So it ends up giving me 1 degree equal to pi over 180 degrees. There's your conversion factor. All right, so conversion factor, I'll write that here beside it. So if you need to convert from degrees to radians, multiply by pi over 180. Now you want to look at it the other way. So we're looking at radians to degrees. So we know converting degrees to radians, multiply by pi over 180. But we go the other way also. So again, looking at our conversion factor, 2 pi radians, of course, is equivalent to 306 degrees. So as we look at simplifying down to 1 radian, we'd multiply or sort of divide out 2 pi on both sides. Right, as we do that, we get 1 radian. And 1 radian is equal to what? 2 divides in 360, 180. So I get 180 degrees over pi. There's your conversion factor. So 1 radian is equal to 180 degrees over pi. Conversion factor, again, for converting from radians to degrees. All right, so you want to know those to be able to convert. So let's go to some examples. We look at this first example. It says, convert each of the following to radians. Leave your answer in terms of pi. So we've got 120 degrees. Well, 120 degrees, one of our special angle measures. And we'll look at it here. This is a 6-degree mark in quad 2. If you wanted to show its location on the unit circle, it's 180 minus 60. All right, 6 degrees is the reference angle between the terminal side and the x-axis. So it's one of our special angles. With that said, we want to convert it over to radians. So 120 degrees, right? We want to know what it is in radians. So again, our conversion factor. So we know that 1 degree, right, is equal to pi over 180. So we're going to multiply by that. So that implies 120 degrees times pi over 180 degrees. And as we simplify, let's go ahead and simplify together. Right, we know that 120 over 180, right, we could go ahead and divide out a 10 on both. 120 divided by 10 is 12. 180 divided by 10 is 18. Tack off the zeros. We know that 6 divides into both. So we could divide out a 6, common factor here in both. So that reduces to 2 over 3. So we end up in the end with 2 pi over 3. So yeah, 120 degrees, our 6-degree mark in quad 2, same thing as 2 pi over 3 radians. So there it is in terms of radians. All right, so again, multiplying by the conversion factor. Let's do the same thing with example B. We've got negative 340 degrees. We want to convert it to radians. So we have it in degrees. So we know that the conversion factor is 1 degree is equal to pi over 180 degrees. So that implies we got negative 340 times the conversion factor of pi over 180. And as we simplify, let's go ahead and we can divide out a 10 on both. 180 divided by 10 is 18. 340 divided by 10 is negative 34. And looking at a common factor, we know that 2, they're both even numbers. Let's divide out our 2 on both. Let's go ahead and reduce. 34 divided by 2 is negative 17. 18 divided by 2 is 9. So we end up in the end with negative 17 pi over 9 radians. There it is in terms of radians. So we got it in radian measure. Now, so multiplying by our conversion factor. So we'll put that up here. Let's write it back up here at the top. All right, so conversion factor, right, is what? Pi over 180. All right, 1 degree equal pi over 180 degrees. All right, moving on, let's go the other way. So say we're given our radian measure and we want to convert it back to degrees. So again, remember our conversion factor. We want to write that down up here, we can. We showed earlier. We know conversion factor from radians to degrees is 180 over pi. Right, we know that 1 radian is equal to 180 degrees over pi. So as we go to example A, we got 7 pi over 6 radians. Well, what is that in terms of degrees? So show work. So we got 7 pi over 6 times what? 180 over pi. And what happens to reduce? Well, we can go ahead and divide out the pi. They reduce. They cancel out. We see that 6 goes in 6 one time, 6 goes in 180 30 times. So that reduces. So we end up with what? 7 times 30, which is 210. I got 210 degrees. And again, this is a 30-degree mark. This is 30 degrees off 180, right? 210 minus 180 is 30. It's one of our special angles, our 30-degree measure, a multiple pi over 6. Right, pi over 6 is 30. Multiples of pi over 4, pi over 3. Those are special angle measures. And we can see them, of course, from radians, degrees. So it's helpful to be able to convert. Sometimes people recognize it when it's in degrees. Sometimes it helps. If you want to be able to convert it over to degrees, you can at any time. Let's look at example B. It's a little different. I've got 8.5 radians. So here's our radian measure, a decimal measure. Now it's not written in terms of pi, so we got 8.5 radians. So we want to convert that over to degrees. Well, with that said, we know our conversion factor. So we're going to take 8.5 and we're going to multiply it by 180 degrees over pi. Well, there's no pi's to divide out, so let's go ahead and get our calculator out. So get your TI out. We'll pull it up, and let's see what we come up with this one. So we'll pull up the calculator on our TI. So 8.5 times 180, right? And then divided by pi. Now you got pi on your TI. I can see it here above my caret key. I can hit the second button, and you don't want to put in 3.14. Put in pi. Don't round your decimal. Let it go as far as you can take it. The calculator has pi on there. Go ahead and type it in. So again, you can see above that up arrow caret key, I've got my pi measure here on my TI. And I hit enter, and out comes my degree measure. So 8.5 radians in degrees is 487.01 degrees. 487.01. 487.01. All right, so let's go ahead and put that in here. 187.01 degrees. All right. So again, that's 8.5 radians. That makes sense. Because then think about 2 pi radians, that's 6.28, right? And pi, which is 3.14 divided by 2, which is around 1.57. Yeah, if you're going to get to 8.5, you got 6.28 plus 1.57. So you're looking at what? Almost again on the positive side of the y-axis 0, 1. As you add pi over 2 to it. And then you're going to be between pi over 2 mark and the pi mark, you're going to be at between, 360 plus 90, which is 450. 450 to, 540. So, yeah, between 450 and 540 is 487.01 degrees, 8.5 radians. We can see that, again, as we look at our circle. We can draw a unit circle to visualize that. But, yeah, distance traveled around the unit circle, 8.5 radians, would put us in quad 2. Put us in there at 487.01 degrees with the rotation. So again, be able to look at it, visualize it, as you're talking about these different radian measures. All right, moving on to a little geometry review. It says here to find a positive and a negative angle that are coterminal with the given angle. Again, coterminal, what? Same initial and terminal side are coterminal angles. We talked about them earlier when we were dealing with degree measures. Now that we're talking about radians, all right, we're going to look at coterminal. And to do that, we got to add or subtract any multiple of 360. So now we're dealing with radians. Add or subtract any multiple of 2 pi. So let's make that note. Coterminal. Add or subtract. All right, any multiple of 306 degrees, or now that we're talking about radians, 2 pi radians. So as we look at number 10, so as we take number 10 here, this example, we got 5 pi over 3. Well, let's do a positive. We'll tie in a positive coterminal. So we could add 2 pi. So what's 5 pi over 3 plus 2 pi? Well, that's equal to what? We can go ahead and rewrite this with a common denominator. We know that 2 pi, if we're going to rewrite it with a common denominator, we can multiply by 3. So we end up getting what? We end up getting 6 pi over 3. And now we have common denominators. We can add them up. 11 pi over 3. There's a positive coterminal angle. All right, well, let's give them a negative. So to do a negative coterminal, right, we're going to subtract a multiple of 2 pi. So we can do that beneath it. So we got 5 pi over 3. And let's go subtract. We'll do a different color. Let's do it in red. So minus 2 pi. All right, which is what? That's equal to 5 pi over 3. All right, minus 6 pi over 3. So again, if we go ahead and rewrite that with a common denominator, so we get minus 6 pi over 3, still minus 2 pi. And we know that 5 pi minus 6 pi is negative pi. Negative pi over 3. Here's a negative coterminal angle. All right, do the same thing with 14. So number 14, what do we have? We got negative 3 pi over 4. Well, let's go ahead and give them, we can do any multiple 2 pi. And I could add 4 pi, I could add 6 pi, 8 pi, 10 pi, 12 pi, 20 pi, any multiple of 2 pi. All right, to get a coterminal, I'm just go ahead and add 2 pi to it. So that's equal to negative 3 pi over 4 plus, now here I need a denominator of 4, so we'll multiply the numerator denominator by 4. Gives us 8 pi over 4. Negative 3 pi plus 8 pi, that's 5 pi over 4. There's a coterminal angle, so positive coterminal. The same initial and terminal side as negative 3 pi over 4 radians. Same exact spot. Where is negative 3 pi over 4? Negative 3 pi over 4 is in the 45 degree mark of quad 3, right? It's negative 135 degrees. If you want to locate it on your circle, well, that's the same place as 5 pi over 4. It's a 45 degree mark in quadrant 3 is pi plus pi over 4. So you can see it on the unit circle also. All right, let's go ahead and do it with negative. Find a negative coterminal. So we got negative 3 pi over 4. And again, I'll do this one in red. So I'm going to subtract 2 pi. As we do that, we got negative 3 pi over 4 minus 8 pi over 4. All right? As we rewrite that with a common denominator, we get 8 pi over 4. And that's negative 11 pi over 4. Negative 11 pi over 4. There's a negative coterminal. All right. How about complement and supplements? So looking at complementary angles, we know complementary angles are two angles whose sum is 90 degrees. All right, or now we're dealing with radians, pi over 2 radians. Got to add the pi over 2. We know supplement, sum of the two angles is 180. Or now we're dealing with radians, pi radians. So we're dealing with 5 pi over 12. Let's take our first example. And number 16. We want to find the complement. So the complement, let's go ahead and start with it. All right, we need to add 90. So to find the complement, I'm going to take pi over 2, 90 degrees, and subtract 5 pi over 12. Well, what is that? Let's go ahead and rewrite that with a common denominator. So we'll go ahead and rewrite that. That's multiplying by 6. That gives me what? 6 pi over 12. Same thing as pi over 2. But now I've got it written in with the denominator that I like. All right, so 6 pi over 12 is still pi over 2. And as we subtract 5 pi over 12, I got pi over 12. Here's the complement. So if you add 5 pi over 12 to pi over 12, you get pi over 2. You get 90 degrees back. Well, how about the supplement? So if I'm going to do the supplement, it's got to add to 180. So we know that's going to be pi minus 5 pi over 12, which is we write that with a common denominator. That's 12 pi over 12 minus 5 pi over 12, which is equal to 7 pi over 12. There's our supplement. So again, you see your supplement. Again, you add to 5 pi over 12 to get pi. You add 7 pi over 12 to it. All right. Now let's look at number 20. That's number 20. That's one of our special angles. All right. And this one we have pi over 6, our third degree mark. Now as we look at the complement to C, the complement, that's pi over 2 minus pi over 6, which we rewrite that with a common denominator. That's equal to 3 pi over 6 minus pi over 6, which is equal to 2 pi over 6, which is pi over 3 reduced. There's your complement. And if we did the supplement, right, the supplement, we can do it beside here. The supplement is pi minus pi over 6, which is 6 pi over 6 minus pi over 6, and that's equal to 5 pi over 6. There's your supplement. So you see the supplement and the complement on those. So again, pi over 2 for complement and pi, of course, for supplement. So a little geometry view, just dealing with radian measures. You can see it there on both examples. So radians in degrees, as we put it all together, just sort of summarizing what we talked about. We want to be familiar, again, as I mentioned earlier, with our unit circle, with our different radian measures, and of course the degree measures, and the corresponding measures between the two you see here labeled. Counterclockwise, clockwise, we're going to use those to help us eventually in evaluating our trig functions. We're going to use a unit circle approach to that. All right, let's finish off our section. So to finish off section 6.4 here, they end off with defining our radian measure. So we talked about the radian measure with respect to our unit circle. Well, what is radian measure? With respect to any type of circle, theta being our radian measure, is the ratio of your arc length to your radius. So in the unit circle, for example, let me write that here. In the unit circle, we know the radius, right, is equal to 1. r equal 1. So that implies theta is equal to arc length. So yeah, in a unit circle, theta and arc length are the same. So you see over here in a picture, but whatever your radius is, right, here's our center rotation. Here's our vertex of this angle in standard position here, theta that I've drawn in, whose terminal side here is in quad 1. Well, the distance from the center rotation to that point on the terminal side, of course, is our radius. And we know the arc length is the distance traveled around the circle. That's S. So you can see again arc length, right? And of course you can see radius. So the ratio of arc length to radius defines radians. Right. So let's use that in some examples. So again, R equals radius and S equals arc length. Right, so we'll see if we can take that definition. All right, and go to example. So here's some problems we run into. It says find the measure of rotation in radians when a point 2 meters from the center of rotation travels a distance of 4 meters. All right, so find the measure of rotation in radians. All right, let's go ahead and do that. So if you want, we can draw in our circle. So get a picture of it so we can visualize what we're looking at. All right, so we're going to look at our center of rotation right here at the origin, the vertex of this angle. And as we rotate, we can picture rotating 4 meters, and it's going to be 2 meters from the center. So let's go ahead and show that in here. They're going to have to be double. All right, so somewhere over here in quad 2, where that would happen, we're going to be double, right, the length that we travel. But there's our picture of this angle, theta. And we can go ahead and finish out this circle. But there's a quick picture of what we're looking at. So here's theta, no problem. So there's theta. And with that said, we've gone 4 meters. And we're 2 meters from the center. So they've given us arc length, and they've given us radius. So just getting a picture of that. So that's going to put us somewhere over here in quad 2 whenever we're double the arc length back to the radius. So with that said, we know theta. Theta is equal to arc length over radius. So it's equal to 4 meters over 2 meters equal to 2. So we got a, what? Angle measure of 2 radians. Right? And again, 1.57, you remember even thinking about a unit circle, sits us up on the 0.01 on the unit circle. There it is in quad 2. Right? That's where our measure is with theta. So there's theta. Theta is 2. Right? 2 radians. And let's go and do another example. Find the length of an arc of a circle of a radius 5 centimeters associated with the angle of 6 degrees. So they give us the angle and they give us the radius. This time we want to know the arc length. So that's what we're looking for. What's the distance traveled around the circle? All right, so let's go ahead and visualize what we have in front of us. So let's draw in our picture. So our first step always, get a visual of what you're given. So again, we have a radius of 5 centimeters. We have a 6-degree rotation. So let's rotate 60 degrees. Right. There's a 60-degree rotation. There's theta. And we look at that, of course, draw it in this rotation. Here's the circle. So again, you can see theta. Right? Now what we don't know is we don't know arc length. So that's our unknown. What is that distance traveled here? We do know the radius. The radius is 5 centimeters. So we've got R. So R is known. And what we know about theta right now is written in degrees. We need to go ahead and convert. That's going to be our first step. So step 1, let's go ahead and convert to radians. All right, because remember, we're defining radian measure, not degrees. So remember, what do we have? We know 1 degree is equal to what? Pi over 180 degrees. There's our conversion factor. So we're going to need to go ahead and convert. If you don't already know, of course, this is one of our special angles. You probably already know it's pi over what? 3. But we can show that. So 6 degrees, let's go ahead and multiply by the conversion factor. So as I times that by pi over 180, we'd reduce 60 goes in 61 time. 60 goes in 180, 30. 3 times, I should say, not 30. 60 times 3 is 180. So we got pi over 3, right? Radians. So we've got it in terms of radians now. So theta, again, arc length over radius. So that implies pi over 3 is equal to S, what we don't know, over radius, which is 5. All right? So again, we got to find S, right? That's our work. Right? So let's go ahead and solve S. So let's go ahead and find out what our arc length is. So as we solve that, well, we'll go ahead and multiply them. We'll clear out the coefficient. So we'll go ahead and times both sides by 5. And as we do that, we get 5 pi over 3 equal to S. And there it is. There's our arc length. So S is equal to 5 pi over 3. Now, if you want to take that, let's go ahead and look at that as terms of a decimal. So let's go ahead and look at it, because the round answer says to the nearest hundredth. So let's go get our TI out and see what that is, 2 decimal places. So on our TI calculator, we can type that in, 5 pi, second caret key is pi, divided by 3. Hit enter. I get 5.2359, so 5.24. So 5.24 rounded to the nearest hundredth. So let's go ahead and put that in. There's our answer. 5.24. And this is in what? Centimeters. There's our arc length. All right, so we found arc length. We found S. All right, so again, using our definition of radian measure. So remember, radian measure defined as a ratio of arc length to radius. So in the unit circle, of course, they're the same, right? Theta always equals arc length because radius is 1 unit. Theta equals S. So I hope that helps you getting familiar with radian measures, getting familiar with circles, getting familiar with the unit circle, because we're going to continue the topic of unit circle into our next section as we define our trig functions. So we're going to look at evaluating trig functions using different points on the unit circle, using different radian measures, right, to help us evaluate.